Hello, my name is Rajan Arora and welcome to my course Essentials of SQL Server Performance for Every Developer. You are watching the video of Module 1 Getting Started Part 5 Table Concepts. If you are new to this course, please start it from the introduction video for better understanding. Thank you. I would like to go through a couple of SQL Server concepts that will come up over and over again throughout the course to make sure that you are familiar with them. We have all worked with tables of SQL Server, but many of us may not have given much thought to how SQL Server actually stores the data inside the table. Typically, table data in SQL Server is stored in the form of cluster index structure. This means the data in the table will be stored in a tree-like structure like you can see on the screen. At the bottom of this tree, we have the leaf nodes of the tree, and this is where the actual data rows for the table are stored. Each of these leaf nodes is what is known as a page in SQL Server, and a page is 8 KB in size. Depending on the size of the rows a table contains, each page will generally store somewhere between 50 to a few hundred rows of data inside of it. What is important to know is that the data in these bottom nodes of the tree is actually stored in sorted order, and that sorted order is determined what is called the cluster key of the table. By default, the primary key of the table will be cluster key. By having the data in sorted order in these bottom nodes, SQL Server can maintain the tree structure like you see over the top of the data. The nodes at the top of the page allow SQL Server to quickly traverse the tree and find the data it's looking for. As we will see in an example on the slide, in the sample database, I have a table named students, and the primary key of the student table is the student ID column. So, student ID would be our cluster key in this case. What that means is that down here in my leaf nodes where the data is stored, my student data would be in sorted order by the student ID. So, in this example, the first leaf node is going to be storing the data rows for students 1 to 100. The second node will be storing the rows for students 101 to 200 and so on. In this top two levels of the tree, we have a series of pointers that will help direct us to the data. So let's say now that we want to find the row for student number 327. We start up here at the root node and it will tell us that we need to go to the intermediate node, that is leaf node, that is in the second from the left. And it is in the leaf node where we will find the data that we are looking for. So you see, we were able to traverse this tree in just 3 operations. Even for tables that have hundreds of thousands or even millions of rows in them, by using a tree structure like this, SQL Server is able to find the data it is looking for in a just few operations. This tree structure that SQL Server uses for storing data is very efficient as long as we are looking up data by how the data is stored in the table. In this case, by the primary key, which is a student ID column. However, we often need to be able to look up the data by some other criteria. Say, in this example, we want to search for a student by their first name or last name. And this creates a problem. Our data down here in the leaf nodes is sorted by student ID. But there is no correlation between a student's ID number and their name. Students' names will effectively have a random distribution throughout all the data pages at the bottom of the table. So, we have no idea where a particular name may be. So, what SQL Server will do in this case is perform a scan of the structure, meaning it will read each and every one of these data pages here at the bottom of the cluster index structure, looking for the data that matches your criteria. For a table of any significant size, though you will have hundreds or even thousands of these data pages in the bottom of the tree, Most likely, many of these would need to be read off the disk. So, there is a significant I/O cost, and then SQL Server will have to use lot of CPU in order to read through each and every row. What we can do though is we can create an index on our table though to help SQL Server finding that data more efficiently. So let's discuss the index in the next video. If you like this video, please do share, like and subscribe to my channel for more such videos. Thank you and see you in the next video.